Hello students, how are you all? I hope everyone fine. So in last class we learned the basic operations on sets, the union, intersection, difference as well as complements. So today we are going to solve problems based on the complements. Okay. First problem, let u is equal to 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. A is equal to 1, 2, 3, 4, B is equal to 2, 4, 6, 8, C is equal to 3, 4, 5, 6. Fine. Okay, there are 4 questions. Simple. As I told, the problems from the set theory is very simple. Individually these problems will be for 1 mark, remember that. So first one is a complement and then removing a from u in the a and remove ಮಾಡಬೇಕು. So which are the elements we have to remove from u? 1, 2, 3 and 4. So the a complement start from 5, 6, 7, 8, 9. That's it. So this is the answer to first question. A complement, removing a from u. A complement andre no, removing a from u. Remember that. A union C complement. So first find out A union C. What is A union C? 1, 2, 3, 4, 5, 6. This is A union C. So what is required? A union C whole complement. And I know these elements we have to remove from u. 1, 2, 3, 4, 5, 6 we have to remove from u. If you remove these 6 elements from u, what are the remaining elements? 7, 8 and 9. The remaining elements are only 3 from u, which is 7, 8, 9. So complement of A union C is 7, 8 and 9. Understood? Okay. Adha B minus C. What is B minus C? Removing C from B. 3, 4, 5, 6 you have to remove from B. 3 is not there, nothing. Okay, no need to remove. 4 we have to remove. 5 not there. Okay, no need to remove. 6 is there, so we have to remove. So what are the remaining elements? Only 2 and 8. This will be removed, this will be removed because these two are present in C. B minus C and C and B in the remove model. So what are the remaining elements? 2 and 8. So what is required? B minus C whole complement. So you have to remove now again 2 and 8 from U. 2 and 8 from U. So what are the remaining elements? 1, 3, 4, 5, 6, 7, 8 remove ಮಾಡ್ತೇವೆ 9. So this is the answer to B minus C complement. So first find out B minus C, then its complement. So 2, 8 we have to remove from U and these are the remaining elements. Okay. So now this is one result. Maybe you remember. Okay. Nan last class alli property center alli kottide. Complement of complement is the set itself. So first find out A complement. Already this part is done. You know. A complement ಇಲ್ಲಿ ಬರ್ತದೆ 5, 6, 7, 8, 9. Now find out again complement of this. That is A complement of complement. Remove these elements from U. 1, 2, 3, 4, 5, 6, 7, 8, 9 removed. And we know that complement of the complement is the set itself. Is it true? Yeah, A is equal to 1, 2, 3, 4. So the result which I gave in the last class, it is verified through this example. So A complement of complement is itself. So I hope you understood these 4 problems under this given data. Right? Yeah, very good. So next question. Again we are using the same operation, that is a complement. Let set of all natural number be the universal set, and the biggest known set here for this problem is a natural number. What we have to do? Write down the complement of these 5 problems. So only you have to write down its complement, okay, and you have to write in terms of set builder form only. Remember that. So if this is A, then what is required? A complement. How to get A complement? What is A first? X is a even natural number. Only you have to remove even natural number from the natural number. So what is the remaining? X is odd natural number. Odd natural number. Even natural number na remove madidmele what you will get? You will get odd natural number. So answer to the first question is set of all x such that x is an odd natural number. Please remember that. Understood? Yeah. So next B. I'll consider the given set as B, which is nothing but x is a prime number. So what is the complement of that? When you remove all the prime number from the natural number, the remaining natural number are known as the composite number. Then x is a composite number. X is a composite number. X is a composite number. But observe here carefully. Can you tell me what are the prime number? 2, 3, 5, 7, 9, 2, 3, 5, 7, 11 and so on, right? These are the prime numbers. So you have to remove those numbers. So composite number anta bandaga, again 1 will not be the composite number. So here you have to take one element, okay, which is actually you will get here. E heading al barodilla, e property al barodilla, that is 1. Anyway, 0 is not there, so 1 is not a prime number, 1 is not a composite number. So the composite anta bandaga 1 barala, so include ಮಾಡಿ 1, done. Okay, so this is the complement of the set. So let me take the third problem as C. C is equal to set X such that X belongs to N and 2X plus 1 is greater than 10. So first you simplify this. 2X plus 1 greater than 10 implies enagate 2X greater than 9. So this implies X is greater than 9 by 2. X is greater than 9 by 2. So what are the elements of C? Actually 9 by 2 and 4.5. So 5, 6 and so on up to infinity. This is C. So C complement and then one natural number in the remove ಮಾಡಬೇಕು. You have to consider all the natural number which is greater than 9 by 2. 9 by 2 andre 4.5. Immediate after 4.5 first natural number is 5. So 5 to infinity. So what is C complement? 1, 2, 3, 4. Only these are the elements of the C complement. If the complement of a set is a finite set, you can just write like this: 1, 2, 3, 4. Understood? So the complement of C is 1, 2, 3, 4. Okay, so let me take the fourth problem as D. Okay, then what is D? Actually D is natural number, X is a natural number here, so it is 8, 9 and so on, even including 7 also. Okay, 7 also included, 7, 8, 9 dot. This is D. So what we have to write? We have to write its complement. ಏನೆಲ್ಲ ಬರ್ತದೆ ನ್ಯಾಚುರಲ್ ನಂಬರ್ ನೆನಪಿರಲಿ 1 ಬರಬೇಕು 2 3 4 5 6 7 ಇಂದ ಎಲ್ಲನೂ ರಿಮೂವ್ ಆಗುತ್ತೆ ನ್ಯಾಚುರಲ್ ನಂಬರ್ ಇಂದ 7 ಟು ಇನ್ಫಿನಿಟಿ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಸೊ ರಿಮೈನಿಂಗ್ ನ್ಯಾಚುರಲ್ ನಂಬರ್ಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್ 1 2 3 4 5 6 so complement of this fourth question is 1 2 3 4 5 6. Understood? Yes, very good. So let me take the fifth question as E. E is equal to set of all natural number x such that 2x plus 5 2x plus 5 is equal to 9, that is 2x is equal to 4. This implies x is equal to 2. Only one number. The set E is nothing but only the singleton 2. Only the singleton 2. So what is E complement? E complement is nothing but set such that x belongs to N and x is not equal to 2. Remaining all the elements, all the natural number you can consider except 2. All the natural number you can consider except 2. So these are the 5 answers to these 5 different statements where we did the complements of the set by considering a natural number as a universal set. Understood what I am telling? So I hope these two set of problems you understood, right? Okay, very good. Okay. So next question, draw appropriate Venn diagram for each of the following. So there are 2 problems here and you are going to write its Venn diagram. Nenpidella Venn diagram anta helodu. Okay, so let me take the first question, that is A union B whole complement. We have to write the Venn diagram for this. So Venn diagram consists of a universal set and it is represented as a square box. Then the 2 sets will be represented using circle. This is A, this is B. So A union B whole complement. A union B and this is a region including both A and B. So its complement and the outside region. This shaded region represent this shaded region represent A union B. Okay, this represent A union B whole complement, because this region which I didn't shade here, it represent A union B, so definitely its complement will be the outside to A union B. So this is answer to first question. Okay, now the next one, A complement union B complement. One day diagram will baribekagate, you can't write in a 2 different diagram, remember that. A complement union B complement. A complement and the region outside B. Okay, B complement again outside B. So their union means again the same, because this is one result you proved in the last class in one example, De Morgan's property. So this again represent A complement union B complement, because this when you write A complement forget about B outside region, when you write B complement forget about A outside region. So here union definitely outside region, these 2 regions are not included. So this is a Venn diagram representation of this set operation. This is a Venn diagram representation of this operation. let U be the set of all triangles. Okay, this is a 1 mark question, simple question. This is a 1 mark question. Okay, let U be the set of all triangles in a plane. If A is a set of all triangles with at least one angle different from 60 degree, what is its complement? If one angle is different from 60 degree, definitely it cannot be an equilateral triangle, right? So what will be the complement? Can you tell me, in set of all triangle, if you remove the set of all triangle with at least one angle different from 60 degree means what? Its complement, at least one is then one angle out of three angle, at least one angle, or maybe all the three angles are different from 60 degree, maybe two angles are different from 60 degree, or at least one angle must be different from 60 degree. So this set is set of all non-equilateral triangle. When you remove non-equilateral triangle from the triangle, you will get definitely set of all equilateral triangle. Set of all equilateral triangle. Why? What do you mean by equilateral triangle? The complement of at least is everything is a 60 degree. Okay, set of all equilateral triangles. Equilateral triangles. This is a complement of the set. I hope you understood. So let U be the set of all triangles. This is a universal set, and we are removing at least one angle 60 degree. So at complement of at least one angle is all angles 60 degree. So when all the three angles are 60 degree, that triangle is known as equilateral triangle. So it is a set of all equilateral triangle. So these are the problems using the complement. These are the problems using complement. Very good. Now we are going to solve some problems based on the cardinal number. Cardinal number and the cardinal number means the number of elements in a set. Okay, now we are going to use some properties of number of elements in a set, and I'll give you the statement without proof, then directly it's problem. Okay, so next part is practical problems on union and intersection using the cardinal number. So I'll give you some results. You will understand this result just by the Venn diagram itself, but proof anywhere it's not given in the textbook, so directly we can assume these results and we can use it directly in a problems. So results are as follows: n of A union B, number of elements in union is number of elements in the first set plus number of elements in the second set minus n of A intersection B. Why it is like this? Observe carefully. Okay, this is U, A and B. So number of elements in A union B and E region, number of elements in this region, it is equal to number of elements in A plus number of elements in B. When if there is a common elements between A and B, it will be counted two times. So what we have to do, we have to remove one. So minus of A intersection B. So what is the formula? N of A union B and N of A plus N of B. See this part, N of A, N of B minus this region will be counted twice. So this region will be counted twice. So one times we have to remove, that is removed here. Minus of A intersection B, N of A intersection B. So please remember this, N of A union B and N of A plus N of B minus N of A intersection B. Suppose there is no common element between the two sets, either A is B, then what is the N of A union B? N of A plus N of B. No need to remove anything because there is no common element, there is no counted twice. So definitely the answer formula is N of A union B is N of A plus N of B. There is no part of N of A intersection B because they are disjoint. Okay, so next, only A, N of only A. See, only A means this part, the region which the shade which I removed from this diagram. This is only A. N of only A means exclusively A. Remember that, no elements from B will be considered. So that is N of U, okay, minus N of A. Sorry. So that is N of only A. Remember, N of only A is nothing but N of A minus B, removing B from A, and N of A minus B. Remember, N of only A, N of only A, and N of A minus B. Only A in this part, shaded, the region which is not shaded. So N of A LE, N of B part and remove more back. Okay, if you remove N of A N of A intersection B, you'll get N of only A. So remember that only A andre A minus B, only B andre B minus A. So remember, N of only A is N of A minus B, and N of A minus B is equal to N of A minus B is equal to N of A minus this region which is common to both, that you have to remove. So remember, N of A only and nothing but N of A minus B. N of A minus B can be calculated like this. Now I'll give you one more formula. It's a big formula when there are three sets in a given problem, and if you want to find out A union B union C, then you can find out like this: n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. So ಸ್ವಲ್ಪ ಕಷ್ಟ ಇದೆ ನೆನಪಿಟ್ಕೊಳ್ಳಕ್ಕೆ, ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. Okay, in some problems this is not compulsory, but it is given in NCERT. So okay, in one or two problems we will follow this. So what is the formula? N of A union B union C ಅಂದ್ರೆ ಏನು? N of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A, and right plus n of A intersection B intersection C. See here why we are adding, because you have to count only once, but okay, whenever you are using this formula, or if you refer the Venn diagram, you will come to know you will be removed twice, but only you have to remove once. So because of that reason you are adding. So this is a homework that you have to verify through Venn diagram. Understand why it is like this using the Venn diagram. You write three diagram set, you will understand why you are adding again at the end n of A intersection B intersection C, because that common part which is common to all the three will be removed twice, but only once we should remove. But okay, whenever you are using the concept, it will be removed twice, so you should bring once, that by adding. Okay, so remember these 5 formulas. You are going to solve problems now, okay, based on these 5 formulas. See here, formula is not compulsory. Even you can use that concept from the Venn diagram. If you find Venn diagram easy, follow for all the problem. If not, use a formula. Okay, first question: if x and y are two sets such that n of x is equal to 17, n of y is equal to 23, n of x union y is equal to 38, then find n of x intersection y. See, as I told, you can use a formula which, okay, already gave 5 formulas, or use a Venn diagram. So I always prefer Venn diagram to answer this problem. But here observe carefully what will happen in this particular problem. One ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ವೆನ್ ಡಯಾಗ್ರಾಮ್ ಯೂಸ್ ಮಾಡಬೇಕಾದ್ರೆ ನಿಮಗೆ ಕಾಮನ್ ಪಾರ್ಟ್ ಗೊತ್ತಿರಬೇಕು. ಕಾಮನ್ ಪಾರ್ಟ್ ಗೊತ್ತಿದ್ರೆ ವೆನ್ ಡಯಾಗ್ರಾಮ್ ಈಸಿಲಿ ಯೂಸ್ ಮಾಡಬಹುದು. ಇಫ್ ಯು ಡೋಂಟ್ ನೋ ಕಾಮನ್ ಪಾರ್ಟ್, ದೆನ್ ಡಿಫಿಕಲ್ಟ್. ವೆನ್ ಡಯಾಗ್ರಾಮ್ ಇಸ್ ಡಿಫಿಕಲ್ಟ್, ಫಾರ್ಮುಲಾ ಮೆಥಡ್ ಇಸ್ ಈಸಿ. ಸಿ ಹಿಯರ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಎನ್ ಆಫ್ ಎಕ್ಸ್ 17, ಓಕೆ, ಹೀಗೆ ಬರ್ದ್ಬಿಟ್ರೆ ಇದರದ್ದು ಎಷ್ಟು ಅಂತ ಗೊತ್ತಾಗಲ್ಲ. ಇಲ್ಲಿ 23 ಅಂತಿದೆ, ಇಲ್ಲಿ ಎಷ್ಟಿದೆ ಅಂತ ಗೊತ್ತಾಗಲ್ಲ, ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಮಿಸ್ಸಿಂಗ್. ಸೊ ಇನ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಬ್ಲಮ್ ಬೆಟರ್ ಟು ನಾಟ್ ಯೂಸ್ ವೆನ್ ಡಯಾಗ್ರಾಮ್. So which is better? The formula, first formula. Okay, union ಕೊಟ್ಟಿರಲ್ವಾ 38, n of A is known 17, n of B is known 23, and this is required. 38 minus 40 equal to n of x intersection y. So therefore what is n of x intersection y? 2. n of x intersection y is equal to 2, and this is a common part. ಹೀಗೆ ಬರೆದಾಗ ಏನಾಗುತ್ತೆ, ಇದನ್ನು 15 ಅಂತ ಬರೀಬಹುದು, ಇಲ್ಲಿ 21 ಅಂತ ಬರೀಬಹುದು. Problem is done. So when you know the intersection, you can use a Venn diagram. If you don't know the intersection, then you should follow the formula, and you can follow the formula like this to get the intersection. n of x intersection y is equal to 2. So the common element, number of common elements between x and y is 2. Understood? Yeah, very good. Next question. In a group of 400 people, okay, 250 can speak Hindi, 200 can speak English. How many people can speak both Hindi and English? Okay, again, intersection part is missing, remaining is known. But ee problem alli, remember, direct agi hige solve ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. You should follow some procedure. That procedure is you have to mention, okay, the set first. So let h equal to number of people speak, okay, Hindi. ಅದೇ ತರ ನೆಕ್ಸ್ಟ್ ಈ ತಗೊಳ್ಳಿ, ನಂಬರ್ ಆಫ್ ಪೀಪಲ್ ಸ್ಪೀಕ್ ಇಂಗ್ಲಿಷ್. Number of people speak English. So take H and E like this. Now write down what is given. What is given? N of H is given. How much? 250. N of E is given. How much? 200. How many can speak both Hindi and English? Okay. And what is this number? Definitely it will be E union H. Andre either E or H, either English or Hindi. So what is required to find out? N of E intersection H, the number of people who speak both Hindi and English. So same formula you are using. So N of E union H is equal to N of E plus N of H minus N of E intersection H. So that is 400 equal to 250 plus 200 minus n of E intersection H. So therefore n of E intersection H is equal to 50. So the 50 people can speak both Hindi and English. So answer to the second question is 50 people. ಅರ್ಥ ಆಯ್ತಾ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದಲ್ಲಿ ಸೊ ಒಂದು ನೆನ್ಬಿಟ್ಕೊಳ್ಳಿ if the given problem in statement form you should write what are the sets, then write down what is given and write down what is required, use a formula or use a Venn diagram, answer this. I hope you understood. Very good. So next question, if S and T are two sets such that S has 21 elements, T has 32 elements and S intersection T has 11 elements, how many elements are in S union T? See, for this particular problem no need to use a formula directly. You can write one Venn diagram to answer this, because yeah, you know the common part, the number of elements which is common to both. How many? S intersection has 11 elements. So first other intersection part. Next, S of a number of elements in S is 21. Andre ಇಲ್ಲಿ ಎಷ್ಟು ಬರಬೇಕು? 9. Sorry. 10 plus 11 21. T 32 elements. 11 already ಇದೆ ಅಲ್ವಾ? So 32 ಬರಬೇಕಾದ್ರೆ next 21 ಬರಬೇಕು. 32. Understood? So this diagram is enough. No need to write the formula, no need to write n of S, n of T. Directly you use or write the diagram and answer it. Okay, this is universal set. So what is required? N of S union T. What is a S union T? This region is a S union T. Alva? This region will be the S union T. So how to get S union T? Add all the numbers which is visible in the diagram. 10, 11 and 21. 10 plus 11, 21. So number of elements at S is 21. 21 plus 11, 32. Correct? So then, so what is the answer? 10 plus 11, 21. 21 plus 21, 42. So number of elements in S union T is 42. So I hope you understood how to use these formulas to solve these problems. If it is a statement problem, okay, the work is like this. If it is just direct problem, you can answer like this. Okay, so still few more problems are there in this application problem, or okay, that I'm going to discuss in next class. Thank you.